Hello, everyone. We're really happy to be here today. Thank you for coming to our talk. That's called Clean Up Your Data Repository. Think how much data plays a fundamental role in your application, and how do you organize it in a clean way? Let's think about how we solve this issue in real life. In any warehouse, in order to function properly, everyone needs to know where each product is. And if he doesn't know, it needs to find out in an easy and ordered way. Also, products needs to be moved around uh, with a clear workflow. If we don't have a solid foundation and clear design, we can clearly end up with something like this. But first, before we really go into the talk, who are we? I'm Antonello, and he's
I'm Alessandro.
Alessandro.
No, no, no.
Of course,
Wrong
no.
order.
I'm Alessandro,
And I'm Antonello.
and we are both Android software engineer at Accenture, working in Milan. In our experience in a consulting company, we learned that customers can ask you basically everything, and you always need to be prepared. Some months ago, this is what happened to us. We were in a meeting refining feature for the next sprint, and the client asked us if we could make a page faster, or at least feel faster from an end user point of view. I will skip the half an hour that I spent trying to convince them that the most correct choice was to optimize something on the back end, like optimizing queries or reducing the data payload. But I won't talk about it because it still hurts. Finally, we decided on an alternative solution. We proposed a data cache right inside our own devices. We were pretty confident because in that page we were using a modern architecture. We were using MVVM, fragments, reactive programming, dependency injection, all of those things that Google wants us to use to be cool Android developer. And so in the end, the customer was happy. We were pretty happy. And we started the sprint a couple of days later. After 2 weeks of hard working, the demo was right around the corner, and this was the situation. I was on fire, Antonello was on fire, the whole office was on fire. But don't get me wrong, the page worked. We made it work by any means necessary. But I don't think I have to tell you that the end result was a complete mess. And so we asked ourselves, why? If you're also wondering, one of the first issues that we had was messy data models. Our data models, this is an example, a simplified version of an item that was representing something on that page. Our data model was containing much more information than it should have had. It was containing JSON annotations or room annotation and specific functions for creating indexes, for example. And what if I wanted to change the JSON library or room library? For example, I changed the JSON library to something else, maybe a custom implementation. And I lose some functionality, and I have to change the name of one of the parameters. We know that with room, I need to create a new migration. And changing something on the database just because you change a JSON parsing library, it's not great. Also, we had components that knew too much. So take a look at this function. It's called delete item from list. And it simply calls an API, deletes an item on the backend, and then when it succeeds, it deletes the same item on the database as well. So it doesn't look too bad. It's a small function. The problem is where this function was written. Well, this function was written on the view model. And trust me on this, we had so many layers of abstractions that this function should have not been in the view model. The view model should have just asked someone else to delete an item and don't know all the details. Clearly, we understood that having used a modern approach wasn't enough. We were not thinking about the responsibilities of each component. Basically, we were not applying the separation of concern principle. like in a supermarket, every product has its own aisle. In a few words, this principle says that in a complex world, the only way to keep everything clean and ordered is to define and follow clear concern and separate this concern between all of the components. Writing code that works, it's never enough. You need to write code that is maintainable, that is testable, and if you need to change one line, you don't have to worry about breaking something else in another feature made by someone else. How do we achieve that? Well, we looked around and we saw that the solution for our problems was implementing an architecture. Which one? Of course, Uncle Bob's clean architecture. In this architecture, usually represented by this diagram, an onion-shaped diagram where each layer has a well-defined role, and each component inside that layer followed that exact role. But unfortunately, every time I show the onion-shaped diagram to my Italian colleagues, this is the reaction I get. I'm sorry for our non-Italian speaker that can't fully get the joke, but I know that you can still appreciate that face.
Alessandro, for me, is the onion.
Why do I get this reaction from people? Well, because when they see this diagram the first time, and they see, for example, databases and UI on the same level, they're a bit confused. And I get that. From a developer point of view, UI has nothing to do with a database. But from an architectural point of view, I will show you that they are actually similar. So let me cut this onion into pieces to make it a little bit easier, like this. The first two most inner layers are entity and use cases. In theory, these layers represent enterprise-level business rules and application-level business rules. But in the context of our Android applications, we do usually have this kind of complexity. So usually entities are just the purest version of our data models, and use cases, the business rules apply to them. The third layer are components that should translate somehow events, data from the inner layer to the outer one, and vice versa. So if I'm showing something to a user, I will find a presenter-like class. If I'm retrieving data from somewhere, I will have some kind of repository class. In the last layer, where there is the UI and data sources is just a name for APIs, databases, we have implementation details that are all of those details that you should be able to easily swap without impacting other things. How do these layers talk to each other? Well, think about it like this. You tap on something and you expect a response from the backend. So you tap on the UI, the presenter intercepts this event, modifies it a little bit so the use cases know what to do with this event. And maybe the use case wants to ask a repository for new data, and the repository will ask its own data sources. And when the data comes back from the backend, the data will traverse back all the layers in the opposite direction. So let's recreate our beloved onion with only the components that we talked about. I will show you also a different grouping of these components. Let's start with this. In 2019, if you are creating a new feature and you're following Google guidelines, chances are that you're using MVVM. But it, of course, applies to whichever MV pattern that you want to use. So we start with an MVVM implementation with a view that shows data to the user, view model that manipulates the data to be more presentable, and a model for the source of everything. But this is not an architecture. This is just a presentation layer. And the presentation layer is not alone. The model can be substituted with our use cases and entity, creating the domain layer. In this domain layer, we do mostly of our own business logic. But also in this layer, we don't have access to real data. Who gives us the real data? The data layer. In the data layer, we find components like repository or data sources that have access, can interact with real data. So showing to you these three layers and talking about implementation of what a clean architecture looks like, let's talk also about the project structure. And seeing these three layers, the natural thing, the natural thing is to convert them into packages. And I have these three packages right here. And I would say this is a good option. There are, of course, pros and cons. One of the biggest pros is that you know clean architecture and you know exactly where to put everything. You, in small to medium project, also finding classes, it's really easy. But there are some, and also if you saw Kotlin native or multi-platform talk before, you can, for example, swap them into modules and change which module you want into Kotlin multi-platform or native implementation. What are the cons of this approach? Well, when the project gets bigger, it's more difficult to find stuff because you will have data, domain, and presentation full of classes. You can, of course, try to divide them in subclasses and sub-packages, but it's going to be messier. Also, for new developer, it won't be easy to join the project if they have no experience with your project structure. And finally, for example, if you have to add a new feature that, even though it doesn't impact old code, it touches every module because you will need to put something in the data module, something in the domain, and something on the presentation. And for example, you will lose build cache from Gradle, and that's not great. Last but not least, there is a different approach, a feature-divided modules or packages. So I think this is the best approach for bigger project and bigger team. For example, if I'm working on feature 1 and Antonello is working on feature 2, we will not impact each other. And everybody is working on its own code. Of course, there are cons also to this approach. For example, where do we put base classes that everybody use? So you have to make some compromises. And of course, we can create, as I said, complex packaging inside of these modules, so you keep everything organized. Uncle Bob has a nice name for this. It calls it screaming architecture, which means understanding what a project is all about only by looking at the top-level modules and packages. But now I will give the remote to Antonello.
Thank you, Alessandro. So, guys, first of all, I will remember you that the right one is the blue one. We can see you over there. Green guys. OK, so now let's go to our beautiful onion representation. And let's try to understand why actually is represented in this way. So I firstly remember our difficulty in trying to understand why different elements such as the UI and the data source were represented really at the same level. And actually, the reason is really simple, and it is described by this dependency rule. So this rule states two things. The first one is that nothing in the inner cycle cannot anything at all about the other one. And second thing is that changes in the outer cycle cannot affect the inner ones. So if you think it in this way, this is just a way to depict the dependency hierarchy that we have here in this architecture. Moving again to our representation, here you can notice that we have a problem. Because if you see the red line, now we have a dependency that goes from the use case to the repository. And this is obviously right, because if you think about your data flow, the use case will query the repository to retrieve some data. But again, if you think about it, following the dependency rule, you know now that the domain cannot be dependent on the data layer. So we have a problem here. So how can we access data from our domain layer and at the same time make it independent from our data layer? Well, here we have the inversion of control principle that comes into play. So if you find yourself in this situation when you have a class that depends to another, and we have a boundary between them, and we want to reverse this dependency, you can do it easily in this way. So firstly, you need to declare an interface before the boundary then implement with a class that interface beyond the boundary. After that, you move the dependency towards the new interface, and you inject the implementation inside your dependent class. In this way, you are able to reverse your dependency. So in this case, now we remove the dependency on the data layer. If you think that here we can also have additional boundary, so if you remember the onion representation, you know now that from the repository to the data source, we have another boundary, potentially. So here, again, we can apply the same principle to reverse the dependency. Another important concept in a clean architecture are represented by data mappers. So imagine that, of course, you have your data that is coming from your repository, and you want to show it to your user at the UI level. So you will pass through all the layers in between. Well, information that goes is represented in each layer in a domain-specific representation. That is basically a model. So we should have, for each layer, different models. In this case, you can see that we have two models. Mappers are just a way to convert one model into another. We have a network model here and a database model, for example. Then we can apply a transformation using our function as domain model that will be our mapper. In this way, we are able to convert our data model in general to our domain model. After that, we are able to show it to the user as a UI model, of course, so another conversion. And here we are using an as UI model. So data mappers are, we are really lot of approach to implement them. One is just creating a simple class with a function, or in this case, as we are doing right now, we are using extension function on the source model. But now, you are thinking about the same thing. And after all of this abstraction and layering, you might be wondering, why the hell do I need so much complexity in my app? Well, as Uncle Bob says in his book, you are an architect, potentially, so you need to recognize when really all these things are needed. So, as he's saying, I quote, you need to determine where the architectural boundary lie, which one should be fully implemented, which one should be partially implemented, and which one should be just ignored. And remember, in general, that over-engineering is often much worse than under-engineering. So for this reason, maybe, in your app, you don't really have so much business logic on your data, and you can decide to remove your use case layer, maybe. Or if you have maybe just one remote data source, to remove also the repository layer. But please be very careful when you take those decisions, because going back after that you have implemented everything is really difficult. And of course, the more layer you are eliminating, the more you are mixing responsibilities between the other components. But now, as we mentioned, our talk is about the data layer. So we are going to focus about this one. So the data layer, as the name implies, takes care about retrieving data that is coming from different data sources and data that will be consumed by the other layers. As in the presentation layer, we use MVVM pattern. Here we are using the repository pattern. So this pattern identifies two components. The first one, of course, is the repository. And to understand its function, just imagine that you need to handle different APIs. So we have an orchestration of APIs called, or maybe you have different data sources that you need to handle. So all these things are managed by our repository that will hide actually the retrieval of the data that comes from your data sources. And of course, The other one is the data source. That is simply represent the source of your data. It can be, for example, a database or a remote service. So in this example, you can see that we have a remote and a local data source. So then a question here arises, but what if the two are returning really the same data? And how can we choose between the one and the other? So if you are thinking about the remote, like we can have a remote service and the local one as a memory cache, for example, you know that the repository will handle cache invalidation logic. Then you will need probably to call again the remote service, then return the data, and then update the cache, probably. The cleanest way to do this operation, instead, is using the single source of truth pattern. So this pattern implies that you identify a component, and that component will be the only true source of your data that you are going to use. So for example, imagine that you are exposing a database, a local database, as a single source. And then when you are going to have fresh data, you will call a remote service, and then you will update your database. But now, we want to clarify all this concept. So we have created, as good developer we are, of course, our showcase app for this talk. But before, I will really like to ask you a question. So, and raise your hand. What do you use to keep updated in the Android world? So for example, how many of you is using the Android developer site? OK, a few of you.
More than I expected.
Yeah, actually, it's true. And what about Reddit? Less.
One
Two for you. Alessandro is a big fan of Reddit. And what about Medium? Yeah, cool stuff there. I agree. Well, me and Alessandro, actually, we firmly think that the only single source of truth of your knowledge about your Android world is identified by this man, the one and only Jake Wharton. I think you agree. Thank you.
An applause for Jake Wharton.
An applause. Yeah, I know. And for this reason, we decided to create our Jackbook app. Oh. So finally, you will have an app to monitor all the online activities of your beloved Jake. You will be able to answer questions like, how can he be everywhere? Is he a robot? But more important, does he sleep at night? For me, no, but it depends. So as you can see, our app is great, and we received a lot of positive reviews. But now let's dig into our code. So as first example, we want to present you an example where we are retrieving data from our single data source. That is a remote data source. So what if we want to retrieve all of Jake's activity on Twitter? Well, to do it, first of all, we create our data source, where we are injecting the Twitter service, retropis service. After that, we implement our function getTimeline, returning a list of feed as single object. And then we perform the call using the Twitter service. Now here, you can notice that we are returning as a returning type the feed object. But actually, if you have a look in the function inside our retrofit interface, with that user timeline, you can see that we have a different type. And this is because this type is a data domain specific type. So it will reflect the result actually that is returned by the Twitter API. So how do we convert the data model into the domain one? We use mappers, of course. So here, as you can see, we decided to implement a mapper as an extension function. We are doing it as an extension function on our data model. So now we have our mapper. We can easily convert the data model into the domain one using our mapper. And we use, of course, the map operator on the list. Great. So now we have our data source. But how we are going to use it? Well, as you might know now, we want to implement a repository pattern. So we are going to create our repository, where we are injecting, of course, the data source. But now you can notice that here we have two data sources. And this is because we are also implementing the single source of truth pattern. So as single source, here we are using a room database, which is a local database. For this reason, when we call the getFeed function, we trigger the API call, but we are actually returning a result, the streams that comes from our query on the room database. So as we are returning it as flowable, as soon as the API will respond, the updated result will be written into the database, and after that will be emitted. And that's it. Great, right? So now you will never miss a tweet from Jake. But, I mean, actually, if you think about it, the app is not really a big thing because it's just a copy of Twitter or a lot less. So we want to create our fabulous Jake app. So let's try to make it more interesting. So why not adding all Jake's activity on GitHub? Well, starting from our implementation, we can do it with no pain. So let's start by declaring another data source into our repository. In this case, the GitHub data source. Since we are using the single source of truth pattern, we are not even touching our getFeed function, but instead, we are just modifying the refresh feed that is performing the remote call. So here, instead of one, we are doing two remote calls on parallel. And the best part now is that just by implementing a mapper, a new mapper on the new data model that we included, we are able to convert it with the same representation of the other one using a domain model. And in this way, the cool thing that we can easily merge the result into one. Cool, right? So, are we done? Not actually. What about page resources? I think that now everyone is thinking about the same thing. Paging library. Our beloved paging library. So now, on behalf of all engineers around the world, I would like to thank you, Google, for providing us a library, a cool library that provides us an elegant way to handle pagination in our app. Me, Alessandro, really, we try to go deep into this library, trying to understand how does it work. But our attempt was meaningless, so we convinced ourselves that everything was working just by magic. So for this reason, in this talk, we're not going into too much detail about the paging library. That we hope that you follow the talk from Florina yesterday. But we want to integrate the pagination in our app. So let's try to do it with minimum effort. So for simplicity, here we're implementing an example using just remote service. In this case, we are creating our Twitter page data source. First of all, you need to identify the data source type that comes from the paging library that fits your APIs. In this case, as we are using the Twitter API, we are selecting the item key data source. After that, you need to provide an implementation of the required function that comes with the item key, in this case, data source, to perform the remote call. Moving to the repository, we create the remote page repository. where we are injecting the data source we just created. Then we expose a function in order to get the paginated list of object. And we are returning it as live data, as you can see. But now we can notice here one problem. We are exposing a function that will return a paged list of fits. But unfortunately, if you want to map the result in your presentation layer, you cannot do it. And this is why, because the paged list class doesn't really provide any function to support item transformation. And for this reason, we found this open issue on the Google issue tracker. Luckily, we can do it, and we can do it inside our data source and inside our data source factory. But now the problem is that if you want to map the result into the domain model as UI model, we're going to do it inside your repository, which is inside your data layer, which is obviously wrong. That's why me and Alessandro try to find a solution for this problem. And here we decide to modify our getFeed function in order to accept the mapper as parameter. And here we're declaring the mapper using a generic type. So the data layer can know anything about the UI model. In this way, we use the map operator on our data source factory, and then we are going to map correctly our model. Then the mapping function will be passed from our view model as, in this example, a specific mapper that is declared as extension function. Now I'll give you to Alessandro the word.
So
again.
You have the paging library inside your project, and what do? Well, you can close Android Studio and go home. Or maybe you can do like we did and ask yourself another question. We love to ask ourselves questions. I don't know why. Can we apply the single source of truth principle to page resources? And the answer is yes. It's even easier than the previous example that Antonello showed. If you are connecting the paging library to the room database, the only thing that you actually need to do is add one function to your DAO. You can see it here, the getAllPaged, that will return a data source factory instead of, I don't know, a flowable or a single or a live data. And then you implement the function from your DAO to your data source. And as always, the room feed exposed by the DAO, it's different by the feed model exposed by the data source. And then you use this function from your data source into your repository. You map it and convert it to live data in the exact same way that Antonello showed you before. And if we add all of the data already in the database, this would be it, because the paging library handles everything for you. But since we know that we are actually storing only just a part of the data inside our database, we need to trigger somehow the retrieval of new data. And if you saw Florina's talk yesterday, you know where I'm going. You're going to do it with the boundary callback. The boundary callback, it's a callback that provides different methods, different functions for retrieving new data during different scenarios. For example, we implemented two functions, the onZeroItems loaded and onItem@end loaded, which are the two methods that are used when, for example, you don't have any data in your database or when you scroll to the end of your source. And implementing these methods, we can easily retrieve new data from the APIs. Final question, I promise. Is the paging library actually clean? So hopefully Florina won't hate us after this, but I'm not entirely sure that it's clean. We had to make a lot of steps to make it cleaner, converting it to live data, to avoiding exposing the data source factory, or passing a generic mapper to map something on the UI model as the UI model. And for example, if you see the diagram of the paging library, there is some strange error from your presentation directly to your data source. So I'm not entirely sure that it's clean. Maybe we will need an entirely new talk only to discuss about how to use the paging library in a clean way. And maybe, who knows, if the paging library is still a thing next year, we will submit another presentation. And this is it. You can find in this slide the link and the QR code for our repository. And this is us again.
Go back, go back. They are taking a photo.
Take a photo, take a picture. It will be also uploaded with the video. OK? Great. I saw all the phones back in their pocket. And this is us again, so you don't forget who we are. If you have some question now, we will do a short Q&A. But if you came up with some question after tomorrow, in 6 months, in a year, in 10 years, maybe not 10 years, but just write us a message on Twitter. And a message from Accenture. We're always hiring, always looking for new people. And there are so many open positions that I'm sure that if you want, we can find something interesting for you. Thank you.